Okay, let's talk about missing numbers. So you are given an array of nums contains undistinct numbers in a range 0 to n. So return the only numbers in the range that is missing from the array. So you have to implement the solution using only all of one extra space of complexity and all of n runtime complexity. So since the number the length of the nums is 3, but you are missing 2, so you return 2, right? Because 0 to 3, you are missing 2, you just return 2. So before that, I have to talk about how do you actually do in bit manipulation. So if you do like this, index, you XOR your index value and value, which is 0, 0, 1, 1, 2, 3, 3, 4. You end up to this equation. Then you have to do the swapping stuff. Then you end up with 2 only, because for 4 XOR 4, right, it's going to be 0 because the XOR formula. So based on this, you can actually find out what's your answer. So in miss equal to num.length. Okay, why would we have to use num.length? Because we can actually just take the last number. So when we traverse the for loop in the nums array, then we can actually know what happened. Because we need an extra number, to be honest. So that would be the initial default value. Then we just have to loop it. So miss will become your index and your value, right? Your value. And also your missing value, which is miss, right? So this would actually turn out to this. But this way is more clear when you're doing when you find out what the value is missing. So you just have to keep XOR every single time. Then you return miss. That will be the solution. And think about how you actually do this while you're watching the table. So 0 and 0, right? Which is this value. And I'm not worried about what happened for the rest because you are still going to implement I and nums_i. And miss would definitely need to continuously XOR your value, right? This is how you actually continuously traverse the for loop. Then you just submit. This is simple, but this is just hard to think about how you actually do in bit manipulation. And the space is definitely out of 1 and time is out of n. And you can actually use two hash set, but that will actually give you out of n space, which is not good. So this is the formula to do it, but I'm not going to suggest you to do that. But this way is more easier because bit comply is faster than integer comply, or even a library comply. So that would be the solution, and peace.